Assalamualaikum and good morning to both of the panels. My name is Mohd Ashraf bin ROSDIH with MATRIC number B081810118 from BEEI course section 1 group 2. So today I'm going to present about my BDP 1, which is development of smart water irrigation system with IoT controlling base. So my supervisor for this project is PUAN NURUL ASHIKIN BINTI RAIS. So for the introduction, what is an irrigation system? Irrigation is the artificial application of water to the land or soil. It is used to assist in the growing of agricultural crops, maintenance of landscapes, and revegetation of distributed soils in dry areas and during periods of inadequate rainfalls. So why is irrigation so important? The first one is essential part of our daily lives. The second one is vast improvement in agricultural production, which is food production. The third one is increased labor employment. The fourth one is assure economic vitality, and the fifth one is aware of the improvement we could make to already marketed products. So for project background, currently irrigated agriculture is caught between two opposing viewpoints, which is some believe that agriculture is inefficient because it grows water-guzzling crops, while others believe that irrigation is necessary for the production of sufficient food in the future, given expected increase in food demand due to global population growth and climate change. Irrigation is important for economically successful agriculture in arid and semi-arid regions, while it is frequently required as a supplement in semi-humid and humid locations. Water is necessary for the human population, as well as other animals, plants, and bacteria around the world, to have a sufficient food supply and a productive environment. So, for problem statement, the agriculture industry is thriving regardless of large-scale or small-scale agriculture. All of those related to the agriculture industry are needing sufficient amount of water resource to ensure the crops maintain its health, but there is also wastage of water during watering process to the crops. So to cope this problem, a new irrigation system is designed with an addition of moisture sensor to overcome the problem. It provides an efficient irrigation to the crops by using an overhead water sprinkler, and the moisture sensor will play its part by identifying the crop soil was in dry condition or wet condition. So the project objectives is, the first one is to develop a fully automated smart water irrigation system by using microcontrollers such as Arduino. The second one is to monitor and control the system through IoT mobile applications such as Telegram. The third one is to create a system in agriculture that can comply on water saving, which is by using moisture sensor to detect the presence of moisture in the soil to help the system identify the soil were in dry or wet condition. So for scope of project, the first one is Arduino microcontroller. Its function as the brain of this project and to control all the components used in this project. The second one is IoT mobile application. Its function to monitor and control the system. The third one is soil moisture sensor. Its function to detect moisture in the soil. The fourth one is DC supply. Its function to supply voltage to Arduino microcontroller and the circuit. The fifth one is DC motor. Its function to move the irrigation bar. And the last one is water pump. Its function to supply water to the irrigation bar. For literature review, there is 3 journals that has been summarized. The first one is Smart Sensor for Automatic Drip Irrigation System for Paddy Cultivation. The other is Balkunan SR, Bhanumathi V, and Setwaran J, 2019. The technique is how drip irrigation is used to enhance the use of water assets for improving the harvest yield. The second one is development in sprinkler irrigation technology in China. The other is Yan H et al. 2020. The technique is how sprinkler water system innovation was in the phase of experimentation and investigation. The third one is a smart irrigation system. The other is Ghosh, Arijit et al. 2018. The technique is how irrigation system which can estimate the moisture of the soil and automatically turn on and off the water supply. So for the methodology part, this is the flowchart of the project. So when the system start to initiate, it will go through the mobile phone app first. Then it will go through the microcontroller initialization. Then it will go through the moisture sensor and read the sensor values. If the sensor value reach the threshold limit, the water pump and motor driver will turn on. And when the sensor value is not reaching the threshold limit, the water pump and the motor driver will turn off. Then it will display sensor value and the data will be sent over SMS to the mobile phone. And that's the end of the system. So for block diagram, this is the block diagram of the system. It contains microcontroller, which is the main component in this block diagram. The input is program code, power supply, soil moisture sensor, and GSM module. The output is LCD display, mobile app, and relay, which contain water pump and motor driver. So for initial result, this is the circuit design. So in this circuit design, Arduino is the main component in this circuit. Soil moisture sensor is used to detect the soil moisture. Ultrasonic sensor is used to detect water level in the tank. GSM module is to monitor the system, and the LCD display to display the value from both sensors. Assalamualaikum. So this is my AutoCAD design for my PSM project. It is for hardware part on PSM2 later on. So if you look at this is the irrigation bar. At the irrigation bar also there is being attached a hose. At the hose you can see this hole that being punched through the hole, and it acts as a nozzle, so the water will be supplied to it. So later on PSM2, motor driver will be installed here, so it functions to move the irrigation bar forward and reverse. So the water will be poured to the soil beneath it, and the water pump also will be installed somewhere around here, and its function to supply water to the hose and will be poured through the hole over here. So that's all for my design, and thank you. So as conclusion, this project is explaining the development of smart water irrigation system with IoT controlling base, which especially for agriculture industry. After the experimental period is completed and the data has been analyzed, showing that this project able to achieve the objective of this project. So for project planning, this is the Gantt chart for BDP 1. The progress of Chapter 1, which include introduction, project selection, and discussion with supervisor, it covers from week 1 to week 5. The submission of progress report, it's on week 6. The progress on Chapter 2, which is literature review, it's on week 7 until week 10. Discussion with supervisor will be on week 11. The progress on Chapter 3, methodology, is on week 12. The progress of Chapter 4, result and analysis, will be on week 13. The progress on final report preparation plus turn-it-in report will be on week 14, and also report correction also on week 14. And the last one is presentation on BDP 1, which is on the last week of the semester. So this is the Gantt chart for BDP 2. It contains the progress of discussion with supervisor, progress of work, project construction, discussion with supervisor, progress of work, project test, Chapter 4 and 5, which is result and discussion, final report preparation plus turn-it-in report, report correction, and the last one is presentation on BDP 2. So that's all for my presentation on BDP 1. Thank you and Assalamualaikum.